Hi there, my name is Shyam Govardhan. I'm a strategic cloud engineer from Sydney, Australia. On stage, I have Henry Suryawirawan, who is also a strategic cloud engineer from Singapore. And we have one of our cloud partners in Gopi Kudravalli. He's based here in the US. So we're really excited to be here to be talking about how you can build some really cool, innovative Internet of Things applications using Cloud Firestore. Cloud Firestore is the next generation document-oriented database built specifically for the cloud. It allows you to spin up real-time stateful applications in a matter of minutes. It is so easy. It allows you to keep your data in sync across multiple devices, even when they're offline. We'll get into more details very soon. So this session is really about building real-time stateful applications. But what exactly do we mean by stateful? Stateful essentially means that the computer or program keeps track of the state of interactions by setting values in a storage field designated for that purpose. So we're going to look at the architectural choices and technical considerations in building an Internet of Things application from the ground up, from scratch. And we're going to marvel at the ease of use and simplicity of Firestore. Who's used Firestore here? Yay. Who likes Firestore? Everybody, right? Yeah. So look, fundamentally, it allows you to keep your data in sync across multiple devices. And you can literally spin up IoT applications in a matter of minutes. We're going to explore, as I said, some of the architectural choices and technical considerations in building an IoT application, marvel at the ease of use and simplicity of Firestore. So with that, IoT is really made up of intelligence. It's really about people, applications, and devices working together to deliver a smart experience. The smartphone, is a perfect example of an IoT device. It allows us to convert data to information. Smart IoT devices take it to a whole new level. They allow us to convert data to information, information to knowledge, knowledge to wisdom, and use the wisdom to make meaningful decisions that will improve the quality of our lives. They allow us to glean actionable insights in the moments that matter, in the moments of commercial intent. So really, speaking of devices, it's really important for us to understand the subtle distinction between a microcontroller and a microprocessor. A microcontroller or an MCU, they tend to be fairly less expensive. They are simpler to set up, simpler to operate, and Arduino, ESP32, Particle are some examples of microcontrollers. A connected coffee machine, for instance, only needs to concern itself with simple routines and tasks. So a microcontroller is perfectly suited for that use case. A microprocessor, on the other hand, they tend to be a little bit more expensive. The Raspberry Pi is a great example of a microprocessor. So, they allow you to install a full-fledged operating system, and they provide features like package management. You can install additional software and stuff, and they also allow multitasking. So, robotics, drones, augmented reality are some typical use cases of where you would use and deploy microprocessors. And it's really important to understand the difference between microcontrollers and microprocessors because the tools, techniques, and protocols that will be used to develop the application will decide whether you'd be deploying it on a microcontroller or a microprocessor. So that fundamental decision will determine what tools, technologies, and protocols you'll be using. So with that, I'll quickly hand over to Henry, who'll be talking about Firestore.
Thank you, Shyam. So at the heart of this demo is actually Cloud Firestore. So what is Cloud Firestore? To put it simply, Cloud Firestore is a serverless NoSQL document database that is built for the cloud. But it's much more than that. Cloud Firestore is more of a backend as a service that not only gives you the database, but also provides like infrastructure that handles moving stateful data between the cloud and your application and devices. which naturally leads us into how it's also an embedded database that continues to power your application and devices to the cloud. So let's dive deeper into Cloud Firestore. As mentioned, it's a document-oriented database, which means that it's designed to store and manage semi-structured data, such as JSON objects. It's completely schemaless, meaning that you don't need to design your schema upfront, so that you can continue to evolve your application without having to worry about coordinating structural changes to your database, and you can update your application as and when you need it. Google fully manages the infrastructure for you, so that you can focus on building your application rather than thinking about scheduling downtimes to install your database upgrades, or even installing the latest security vulnerability patches. It gives you a full serverless experience, so that you don't need to think about machine sizes like CPU, RAMs, number of nodes, replicas, disks, or even networking. All of these are packaged with pay-as-you-go pricing that can scale down to 0 when you don't need it. Cloud Firestore is super simple to set up. You enable it from your project, download and install the SDK in your apps, and then you're ready to go. Like I said, it's more than just a database. You can access it directly from your application without having to write any middle tier that sits in between. You can secure this direct connection with a combination of declarative security rules and integration with Firebase Authentication. What these rules allow is that it can manage the request that comes into Firestore. You can allow it or deny it based on what the request is, who the sign-in user is, and how it compares with the information stored in the database. And what makes Cloud Firestore more than just a database is the real-time update capability. Cloud Firestore doesn't give you just the database, but also handles the pushing of the updates, synchronization of the changes from the database with your app in real time. So we're going to see that in the demo as well. Which brings me to the last embedded database piece. Firebase Sdks for the Firestore actively cache data in your app, so that you can write, read, listen to, or query data even when the device is offline. The mobile and JavaScript SDKs for iOS, Android, and browsers give you the local embedded database that syncs with the cloud when there's an active connection. And it also has this nifty feature called latency compensation, which basically handles pushing of the updates to the cloud, okay, and then unblocking the UI and also giving you more freedom in your app. Talking about Firebase SDKs, there are some crucial components that are also included inside. The first is Firebase Authentication, which supports signing in user based on passwords, phone numbers, and other popular identity providers such as Google, Facebook, Twitter, or GitHub. Security rules, as mentioned, provide access control and data validation in a simple and yet expressive format. Cloud Functions lets you configure events, such as when you add new document to your collection, and you can trigger a function from there. So it lets you extend your application even further into the cloud. We have implemented some Cloud Functions for the demo later on for the real-time object detection system, and we're going to see it shortly. Next, Firebase Cloud Messaging lets you reliably deliver messages at no cost. And lastly, Firebase Remote Config. It allows you to change the behavior of your app without requiring users to download an app update. You can use this for scenarios such as A/B testing, dark launches, canary release, or feature toggle. And Cloud Firestore is not just for Firebase project. You can use it for server-side as well. It supports multiple server-side languages like C#, Java, Go, and so on and so forth. It supports both REST and gRPC APIs, making it accessible from any environment. It's designed for reliability with 5 nines availability target. The multi-region replication ensures that your data is durable and highly available even in the face of the natural disasters. And it can scale on demand based on the most demanding workloads that you have, so that you don't need to think about connection pools. And it's highly suited for scalable compute infrastructure such as Kubernetes Engine or App Engine. And it can both scale up when you need it or scale down when you don't need it. So I'll hand over to Gopi, who will run through the architecture and implementation of our demo. Yeah.
Yeah. Thanks, Henry. So let's look at the architecture and implementation, right? So if you look at this, we're actually using Firebase. Firebase is like a Swiss Army knife, right? It has a Firestore, it gives you storage, it gives you cloud function, it gives you hosting, and it also gives you authentication and authorization capabilities, right? So what we're doing here is we have an IoT device which captures data, telemetry data from the sensors mounted on a Grow Pi Plus, and it pushes the data in real time to Cloud Firestore, right? On the other hand, the picture captured from the camera module is pushed to the cloud storage, right, which is basically Firebase storage. So Firebase storage is essentially a Google Cloud Storage location, which is accessible through Firebase admin SDKs. So as the pictures keep arriving in the Firebase storage, we actually return a simple cloud function that gets triggered. The cloud function basically invokes Vision API calls, right, and all it does is it detects objects within the image and assigns labels to the detected objects. So all these outputs are basically written back to the Cloud Firestore, and the UI, the user interface basically is hosted using Firebase hosting, and all the authentication is basically done using Firebase authentication. So there are a lot of providers which you can use. So right now in our demo application, we are using Google Cloud Auth sign-in. For authorization, we're actually writing security rules for authorizing access to services like Firestore, storage, etc. Right? So that's the simplistic version of the architecture that we have developed. So you can basically extend this simple architecture to interact with your own suite of machine learning services. So if you look at the machine learning spectrum, on the left-hand side you have a whole range of ease of use services like Vision APIs, or if you want to extend it, more customize it to your use case, you can basically use Cloud AutoML, or you can further customize, build your own, bring your own data, build your own models using a cloud machine learning engine, right? So how many of you like Python? Can you raise your hands? I like Python. How many of you like Node.js? Okay. And how many of you like Go? And how many of you don't like any of these? Right. So what we have done is the cloud function that we have developed, the initial version was in Python 2, right? And it was all traditional making traditional synchronous calls. So if you look at the components in our Python cloud function, we basically have four major tasks, right? Which is an object detection, a label detection, a web entity detection, and a URL generation, right? So what we have done is we have taken the initial version of the Python code developed by Shyam, and we have kind of made it asynchronous using Node.js. You can as well make it asynchronous using Python 3 using async.io, and if you are a Go programmer, you can basically use Go routines, right? So this is the asynchronous representation of the cloud function that we have developed. And if I dive deep into each of the functions within the cloud function, right? So this is a simple function for object localization. All it does is it takes the image input from the GCS bucket, right? It instantiates an object of Cloud Vision API, and all it receives is coordinates of the bounding boxes, which are just the vertices of the bounding boxes, right? That's what we get as response out of object localization. The next API is we are actually using object localization. So label detection, which is basically assigning labels based on the objects that are detected within the image. And the third one is web entity detection. So for the image that you actually give it as input, it actually searches on the web and gives you labels for the image. And finally, we have a function for generating signed URLs for the images from cloud storage, so that we can populate that onto the UI. So if you observe in Node.js, what we are using is we are implementing promises, right? So basically your promise objects, once they get resolved in an asynchronous fashion, we actually collate all the responses, create an image document which has all the responses from object detection to label detection to web entity detection to your signed URL, and we basically write this object inside a predefined collection in Cloud Firestore. All right, so let's look at the demo.
Great. Who is a 100% believer that live demos at large conferences in front of large audiences always work?
I'm
Well,
optimistic.
we're going to find out very soon. So, what you're looking at here is a smart environment monitor and an object detection system. So, essentially, it's a rig that I put up together, and it features a Raspberry Pi 3 Model B+. Who's played with one of these? Many of you. Okay, good. Who's played with a Sense Hat? Good, a few of you. So you see the Raspberry Pi 3 Model B+ has those GPIO pins at the top. The Sense Hat here is, comes with a bunch of sensors, but the ones that I was particularly interested in is a gyroscope and an accelerometer. So what you can do is essentially take the Raspberry Pi and the Sense Hat and connect them both together like so, using the GPIO pins. Yeah? And the third piece to the puzzle is what's known as a Grove Pi Plus. You can pick up the Raspberry Pi 3 Model B Plus for about $35 US. Sense Hat is about the same cost as well. And this thing here, Grove Pi Plus, is from Seed Studio. And it comes with a few connectors that allow you to hook up sensors. So you have 3 analog sensors connectors to the left. You have digital sensors connectors at the bottom. And you also have other I2C connectors on the right as well. So essentially, the Sense Hat and the Grove Pi Plus are essentially known as hats, hardware attached at the top. So you can literally take it and hook it up directly on top of one another, just like so. And what I've ended up with is basically exactly what I've described over there. And what I also have is a bunch of sensors connected to the entire rig. So I have a light sensor on the top left-hand corner. It basically detects fluctuations in the light levels. The sound sensor, obviously, it detects the fluctuations in the sound level. The angle sensor, it's a knob. It basically allows you to twist it left or right. And I'm using it to control the rate of transmitting telemetry data to Firestore. Essentially, it's a potentiometer in electronics terms. So when you turn it full, all the way up, it sends it fast. And when you turn it down, it sends it slow or so. And here you basically have a flame sensor. I was told that I couldn't light a match or a lighter here on stage for safety reasons, so it ain't going to happen. You also have a button here as well. When you press the button, the web camera will take a photo. And there is an ultrasonic sensor, and that sensor basically checks the proximity reading. So as you move an object further or closer to it, it will detect that. And what actually happens is all of these readings get uploaded, transmitted to Firestore in real time. And that's the beauty about it. What use is an environment monitor if it's not in real time? You don't want to know that your house is on fire 5 minutes ago. You want to know if anything is happening right this very moment. So real-time nature is critical. And it's for that very reason I felt that Firestore was a perfect fit. I can't think of any other solution that will give me that feature and functionality. So essentially, this is basically what my first version looked like. I plugged in all those sensors. And as it says here, my first version also used Google IoT Core and Google PubSub as well. PubSub is an asynchronous message broking platform from Google, which is part of Google Cloud Platform. And Google IoT Core allows you to create a device registry, a central registry of all your IoT devices. For this particular use case, I just stuck with Firestore because it was much simpler to demo. And this here was the final version of what I ended up. So the previous version of the Smart Environment Monitor only featured the 6 sensors. The next version also included a Logitech webcam connected to the USB port of the Raspberry Pi. And I also connected a speaker to it. In this instance, I actually have the audio connected to the central audio speakers there. I also have a little travel router here. So the entire rig basically gets its IP address and internet connectivity using this travel router. So I can just take it around wherever I want. So with that, let's dive into it. Henry here is going to focus. If we could just focus on the rig for me, please, Michael. Great. So here, this is basically what it looks like. As you can see here, there is a Raspberry Pi at the bottom. You have a SenseHat on top. You have the Grove Pi Plus on top of it. And you have all of the sensors connected at the top over here. And we will be interacting with it. Can we please switch to my laptop? OK, first things first. I want to make sure that everything is up and running. I don't want to start a demo and find out that everything's broken behind the scenes. Because albeit this is a hack that I've created, it's not a production quality Samsung technology. You can build this up for about $100. So anyway, first thing I want to establish is the process running? OK, so when I do that, that basically tells me that there is a daemon, a process that's running on the Raspberry Pi. So essentially, a daemon is a program that basically runs constantly, and the operating system basically will restart it if for whatever reason it dies. Okay? Now, one other thing is, as you can see from the status, it is generating its log files. It's generating a log file here. So let me tail it. So this is basically telling me what the actual program, the Python program, is doing. Now let me now press the button. OK, you can now see what happened. I click the button. The webcam captured a photo, or I think of a few objects. Hopefully I'm aiming correctly. The telemetry reading is displayed in the log file. It's telling me everything from the light reading, the sound level, orientation, accelerometer, and a few other things. It's played a wave file for the shutter sound to indicate that something actually happened. It's used the FSWeb program to basically capture the photo. And it's uploaded the photo to Google Cloud Storage, which is essentially like a giant file system sitting in the cloud. So you can just, upload files to it and not worry about it, because then you can have the cloud handle it. Yeah? So that's pretty much what I've done. So let's do it a few more times. Let's try and see how Ralph is responding to this whole thing. He seems pretty happy. This is from Wreck-It Ralph. So there you go. There you go. How about this elephant from India? Or this little mermaid lion from, and I don't know if it's going to detect the Eiffel Tower. Let's check. And there is a horse as well. OK, there you have it. Put them all together. Ralph in the middle. Let's snap away. Let's take a picture of the audience. Smile. Good. One more. OK, you get the drift, right? Pretty easy, pretty obvious. So what? No big deal. Now, my colleague, the partners, just bear with me. Can you, just one moment? Our partners at Quantify, Nilay Kamat in particular, he's a very talented software engineer. Unfortunately, he wasn't able to be here at this conference. he's come up with this beautiful dashboard, and it shows you all of the photos that are just captured. Okay, that's real time for you. Okay, a cheap little contraption with commodity hardware, $35 Raspberry Pi, and a webcam, capture a photo, publish it at will to the cloud, and you have a cloud function that's constantly listening to those events, and it's basically gone and done object detection for you. It's done object detection, and it's drawn a bounding box around the object that it detected. Okay, and it's used the localized object feature of Vision API, and it's also used the label detection feature of Vision API to come up with a word cloud. Okay, and essentially, look, I'm not an AI expert, I'm not into machine learning, I'm just a software engineer, but I was able to literally leverage Google Cloud Platform to spin up a fairly useful, practical, so to speak, object detection or surveillance system, as well as an environment monitor with little to no effort, very little code. Okay? You don't need to have a PhD in AI to come up with something like this. Let's see if it detected anything about you guys. Oh, there's people here. Surprise. And one of them is smiling. Event, oh, there's a convention. There's a convention, there's a crowd, there's an audience. That's pretty impressive. Let's see what happened over here. It's detected an Indian elephant. So if you ask me, that's all pretty impressive. So this is Vision API in action for you. Okay, it's also detected Wreck-It Ralph, and it's a person with muscle and physical fitness. Come on, tell me you're impressed, right? Give me some sign that you're impressed. Come on. Thank you. Thank you. I'm working hard over here. Yeah. So you guys get it. Okay. The next thing I want to show you is you get the idea about what's happened behind the scenes. Vision API, localized objects, which gives you the bounding boxes, XY coordinates and whatnot, and also the label detection. Now let's look at telemetry stats. Look at how fast the telemetry readings are getting updated. Now that, again, ladies and gentlemen, is real time for you. Okay? I cannot think of another technology that is better suited than Firebase or Firestore in this particular instance, where I can just pump real-time telemetry data to the cloud for it to get visualized in real time, just like that.
Move something. Move something, your hand, lights.
Oh, yeah. What do you want me to do? Oh, light. Oh, yeah, okay, good. Henry here has a good suggestion. Check that out. I'm moving my hand right above the light. Check out the light reading on the top right-hand corner. It's gone all the way down. And take my hand up, 755. How quick was that? That's pretty cool, right? Okay. Look, I can go on about this, right? There is also a D3 dashboard. You know, this is an earlier version of the dashboard that we created. And this also shows you things like the ultrasonic sensor. So for instance, if I move my hand, you can see the sonic reading fluctuate. Okay? That's real time for you again. You need to know what's happening right this very moment, across devices, across geographies, as and when it happens. I can't think of any other technology that'll make it happen other than Firestore. If I pressed a button, how long did it take for the button to flash? Instantaneous. If I move this rig, see the globes move. Okay? That's the gyroscope and accelerometer in action for you. So that's, we are there, demos, other sensors. Okay, let's look at how it's working behind the scenes. Okay, this here is Firebase Console. You can go to Firebase, you can just look up Firebase Console. That is how fast the telemetry readings are being sent by this Raspberry Pi to the cloud. At 1 second intervals, extremely fast. Here you have the accelerometer readings, and you also have light reading over there, You have the orientation with the gyroscope readings,
Timing.
sonic level readings, which is the proximity reading, and so forth, and temperature. All this is happening rapidly. You know all those photos that we just took? Where are they? This is a collection. Firestore basically has this concept of a collection and documents. So essentially, in this document, you have multiple collections. So you have multiple tags assigned to that one photo. So in this particular case, you can see floor, flooring, hardwood, and so forth. So it's pretty easy. Okay? You can also see the bounding box coordinates. These are the diagonal x and y coordinates so that we were able to draw the bounding rectangle. Okay, you can see what's happening here. We had events happening on the Raspberry Pi. It gets published in real time to Firestore. The image gets published to cloud storage. Cloud function kicks in. It does object detection. It generates bounding box rectangles. And it does label detection and so forth. And you were able to see all that instantaneously.
4 minutes left.
No worries. And then you also have this thing called a cloud function. Okay, cloud function is basically serverless technology. This is basically what it looks like. So if I went into cloud functions here, let's look at Python. And here you have the source, and this is basically it. And this is look, Python, it's a trivial piece of code. I don't have time to actually go through it, but it's literally less than 100 lines or 200 lines. Pretty easy. But okay, this is where the fun begins. We want you all to participate in this demo. We'd like to gamify this. We're going to give you exclusive access to two of the most talented engineers in San Francisco, my friend Henry and Gopi over here. Exclusive access to these two guys who will give you a personal 30-minute session to do what you please with the IoT rig. All you have to do, that card that was handed out to you, please scan the QR code or visit next.shyamg.com, and from the drop-down box that you see there, select one or more tags. As you select one or more tags, we are keeping a tally of who's clicking on what. Could I please get you all to participate in this live demo? This is basically demonstrating real-time IoT at scale in action.
So you go to image pool.
So basically go to image pool on that, once you arrive there, and click away. Click away on different labels.
No problem.
We have a couple more minutes. If I could please get you all to click away.
The more, the better.
The more, the better. Click as many times as you want. Because there is a punchline to this. There is a purpose to this. Okay, as you can see here, as you select these labels, the images get updated instantaneously. Are we good? How much time do we have?
Show the stats now. So
Okay, let's now look at the stats. Let's look at user stats, and there you have it. How long did that take, ladies and gentlemen, to come up with a live histogram of all of the selections that you made over the last minute? That, again, is Firestore for you. Who is B. Vol Chow at GoSpot Choc Check? There you go. He's the winner, so it seems. So this is getting updated in real time. Thank you all for your support. And I would personally like to thank my partners at Quantify for the great work. I'd also like to personally thank my friend and very talented engineer in India who wasn't able to be here, Nilay Kamat. But please feel free to reach out to us at the Quantify booth after this session. Thanks again.